All right, class, welcome back. So this is an interesting problem that we're gonna try to do here in example 2. So this is related to the optimization problem section. A manufacturer has been selling 1,150 television sets a week at a price of $360 each. A market survey indicates that for each $10 rebate offer to a buyer, the number of sets sold will increase by 100 per week. Find the demand function P of x, where x is the number of television sets sold per week. So a friendly reminder that P of x it's the price value, right? Where x is the number of television sets per week. So in this example, we're actually gonna follow two types of problems, right? It seems like there is a linear correlation between the increase between the decrease of price and the increase of sales. So what we're suggesting here is we are going to have a relationship between y minus y1 equals mx uh, times the quantity of x minus x1, right? Where m is equal to y2 minus y1 all over x2 minus x1. Okay. So we have here, these are they're gonna be kind of important for the part. So what we're gonna do here is we're gonna look at the change. Let's find the change between the price and the number of units sold. So let's compare the two numbers. So if we start at 1,150, right? If we say that the first that we if we have number of items comma price of item, this will be if we have an order pair like this, we can compare the two relationships, right? Number of items sold at a price of 360, and we can kind of compare the change by using another point that relates to this relationship. The other point will be, well, what happens if we decrease the price by $10? That means we're gonna sell 100 more TVs, so 1,150 plus 100 will be 1,250, and the price will be from 360 to 350, right? You're gonna decrease the price. So in other words, this will be the change, right? So if if we try to measure the slope of this, the change of this, this actually is going to be m equals, right? So it'll be y2 minus y1 over x2 minus x1. It'll be 350 minus 360 all over 1,250 minus 150. This will be minus 10 over 100, which equals 1 over 10 as a slope. And then we can use our linear equation to come up with a linear relationship for the demand price, the demand function, where we know that P of x is our y. So we'll say that following the y minus y1 equals m times x minus x1. Our y is our P of x. Our minus y1 will be one of our points, which in this case 360, or our original price. And then m is the slope that we just found, which is negative 1 over 10. And then times x minus x of 1, which is the original number sold. And there you go, right? We have found an equation. What we need to do here is solve for x, so we would distribute so this will give us P of x equals to minus x over 10 plus 1150 over 10, that's 1105. And here we would also add the 360 on both sides of the equation. So this will give us demand function is equal to negative x over 10 plus 475. Right, so we found the demand function where x is the number of televisions sold per week. Okay. All right. The next part of the problem is asking us to find how large a rebate should a company offer to a buyer in order to maximize its revenue. So how much as a discount, right, should we have? How much of the discount should we give the buyer in order for us to maximize our revenue? Okay, so we need to maximize what? Revenue. Do we have revenue? Are we given revenue? We're not given revenue. But we know that revenue is quantity times your price. So we know what x is, it's x, and the price is the demand function. So what we gotta do here is distribute. So we end up getting negative x squared over 10 plus 475x. So that's our revenue function. In order for us to maximize it, we would need to find the critical numbers for this. So in other words, find the derivative. So the derivative of this will be bring down the power. That'll be negative 2, leave the constant as it is, which is the 10, and then leave the x as it is, and then subtract 1 from the power. The derivative of 475 times x, what we do is here we drop the x, and that's it, right? And maybe, and then we're gonna set this equal to 0 to find the critical numbers. We will also try to find where this is undefined, but since we know this is a real number, we're not gonna have this case. Right. So now we're gonna simplify this, and we see this is simplified to be negative x over 5 plus 475 equal to 0. Maybe I don't need this side over here. And we can solve for x by adding x over 5 on both sides of the equation and having 475 equals to x over 5. To solve for x, we will multiply both sides by 5. So therefore, we get that x is equal to 475 times 5 is 2,375. Now this is a critical number, but we don't know whether this critical number will actually give us a max. This could give us a minimum, right? So what we need to do is we could just take the second derivative, and the second derivative of this by looking at here, it will be negative 2 over 10 because you drop the x and the derivative of 475 is 0, which we know this is negative 1 over 5. But anyways, this is less than 0. That's negative. And that means that negative second derivative, that means concave down. So what does that mean? Our critical number is a concave, it's a max. So we're good so far. But let's see what we have, right? So how we found the number of items we need to solve to maximize, but that's not the question. The question is how large should the rebate be to offer a buyer in order for us to maximize our profit. So we need to know how much of a difference of a price, right? How much discount we gotta um, give them to make sure that we are going to maximize the profit. So we're gonna find the price of this. How much is the price to maximize our profit? Well, the price to maximize our profit can be found by plugging um, in the 2,375 into the price function. Right, so we compute this, and this will come up to be $237.50. But that's how much you have to charge, for us to maximize. But this doesn't tell you how much is the rebate. The rebate is how much you're putting down the money. So how much discount you're gonna give. Well, we already know how much is the original price. The original price is how much? 360. So we will take the 360 and subtract $237.50. And that will give us $122.50. So for the revenue to maximize, we need to give a rebate of $122.50. Right. All right. So that was interesting. Let's try the next example. The next example is asking us if the weekly cost is 69,000 plus 120x. So the cost function is 69,120 plus 120x. How should it set the size of the rebate to maximize its profit? So they're kind of asking us almost the same thing, but in this case they're asking us for the profit, not just the revenue. So we get a little more information in this example, and so, but again, the focus is that they tell us what we're maximizing. We're maximizing the profit. Are we given the profit? No, we're not given the profit, but we know how to find it. We know by the fact that the profit is the revenue minus the cost. And we're given the cost, and we already have the revenue. So what we can do here is just subtract those two. So the revenue is negative x squared over 10 plus 475x. And then the cost is 69,000 plus 120x. And of course, this is a game of making sure that you have your parentheses right, because if you do, then we'll miss out the distribution of the negative. So we end up getting negative x squared over 10 plus 475x minus 69,000 plus or minus 120x. Right, so we will combine like terms, and we are getting negative x squared over 10 plus 355x minus 69,000. There you go. And then maybe I'm gonna move this a little bit to the right. Okay, to get a little more space later on. And so this is what we're trying to maximize. We just found the equation. Now let's find the critical number and make sure we optimize it. So find the derivative of this, bring down the power, subtract 1 from the power, divide by 10, plus 355, right? Drop the x, and the derivative of a constant is 0. And of course, we're going to find out whenever this is equal to 0 or whenever the derivative is undefined. But we know that this is not going to be the case since this is a polynomial and is always defined. But nonetheless, we still have to go through the motions and make sure that that's not going to give us another critical number. So let's go ahead and solve this. We know that negative 2 over 10 is negative x over 5 plus 355 equals 0. Of course, we're going to add x over 5 on both sides of the equation. X over 5. That cancels. So therefore, we're going to get x, or maybe I can just write it here. It'll be 355 equals to x over 5. Multiply both sides by 5. And that gives us the x should be 1,775. Okay, so that will be the number of items we need to sell and produce to maximize our profit. But that's not what they're asking us. How should it set the size of the rebate to maximize its profit? So that means we need to figure out how big is the rebate needs to be to maximize the profit. We need to find the price and then compare that to the regional price. So how much is going to be the price level when we are producing 1,775? So we know that the price function is negative 1 over 10 x plus 475. So now if we replace 1,775 in here, we compute that, and that's going to give us 297.5. And that's the price that will give us maximum profit, but we need to see what's the rebate, what's the size of the rebate. So to do that, we're going to take the original price and subtract by this new price, and this will give us $62.50. The size of the rebate to maximize the profit needs to be $62.50, right? So this is how big is the discount, right? For us to maximize our profit. If you notice, this is interesting, that is if we compare the revenue and to maximize the revenue versus maximizing the profit, you get two different numbers, right? And that is because we are taking into account that the profit deals also with the cost. So we don't need to so that plays a factor into the profit and into the process. So what I'm saying here is it's not going to be the same, right? To maximize the revenue is not going to be the same as to maximize the profit, because there's a factor of the cost that is not implemented in the revenue. So anyways, I hope you guys found this helpful.